We will have the next presentation today, this time about flame retardants for basically all composite production methods and a little bit off topic as well, MgO thickeners for SMC and BMC productions. This presentation will be held by two persons. One of them is here beside me, Thomas Fehling. He is our business unit leader at Lehmann & Voss for the composite division. And myself, my name is Mike Luca. I'm working as his technical sales manager in the same division. Everything's okay? Okay. We splitted this presentation in three parts. I want to start with give you a short introduction into our company so that we can make clear why we can talk about these topics. Then I will hand over the microphone to Thomas, who will explain you flame retardant solutions for the composite industry. And last but not least, I will explain MgO thickeners for the SMC industry, how they work and what they are doing and what you should consider when you use them. As I promised you, I will start with a short introduction into Lehmann & Voss. Our company is based in Hamburg and over 130 years old. We started with MgO since 1894, and since 1907 we changed our focus to on-site technician solutions for our customers. So we opened our first technical laboratory, and from there on we were growing into different business units, and one of them is the composite business units. Right now we have over 600 people working for us. We have 4 production sites, 2 in China, 1 in the US, and 1 in Hamburg in Germany. We have right now more than 7,000 customers and more than 6,500 products, which shows already that we are kind of used to have tailor-made solutions for our customers. As I said, we are divided into different business units. Composite is only one part of it. We have also from 3D printing over life science, raw materials for coatings, special and high performance compounds, many units working in different fields, which are sometimes kind of overlapping, like we are working closely together with the coatings division, and of course we're using our colleagues from the magnesia division to produce the Louverture, the MgO thickeners for the composite industry. Our business unit, Composite Materials, we divided our products into 3 applications. One is SMC and BMC, so 2. We produce the Louverture, so the MgO thickeners for this application. We have flame retardants, which will explained by Thomas a little bit later, carrier film, and all kind of other additives as well. We are also really active in the field of pultrusion. We produce, trade, and sell internal mode release agents. We have, again, flame retardants for pultrusion more on the liquid side. We have P-Apply if it comes, for example, to spark caps, and also all the other performance additives you need for successful pultrusion part. Last but not least, we are serving the wind energy as well. So with a lot of consumables, we are doing and sale to the wind OEMs for production of rotor blades. That's so far to the company. Now I will hand over to Thomas, who will explain our flame retardant solutions to you.
Thank you. Thank you, Mike. So, hello everybody. Let's talk about fire. Well, what you see here are some pictures of our application laboratory. So we have a UL94 burning chamber and also a device to measure the LOI, also known as low oxygen index. So flame retardants are a very diverse group of different chemicals. So you can talk about halogen-free materials, you can talk about halogens, you can talk about metals, phosphorus or nitrogen materials, so on and so far. Each chemical has a different effect. First of all, we have to make a difference between physical and chemical effects. So what is the reason to use a flame retardant? First of all, your composite material is a good fuel to keep the fire burning. And a flame retardant, for instance, will never avoid a fire. What you get is time. Time to save people, time to distinguish the fire. So the highest restrictions, the highest regulations you have is in transport for vehicles, train, for example, and in construction and building. So when we're talking about fire, you have to be aware about some wordings. So what is your material? What is your combustible material? Also called as the fuel for the flame. Is it a chemical reaction which causes the flame? What is the source of ignition? Is it an exothermic reaction you have? What is very difficult to avoid. Do you have a chain reaction or, wait a second, and what is, last but not least, your ignition source? Is it heat? Is it a chemical reaction? So on and so forth. And what about the humidity of your environment? When you put a flame retardant into your composite, what do you try to achieve? Most of all, you have different kind of standards. You are with different regulations and different levels of flame retardant effects. The most restrictive ones are trains and vehicles. What we have here is the German standard 5510, but it's better known under the European standard EN 45545. That is the mother of all standards, I would say. But you have also standards for building and construction. You have the UL 94 test, which is also an orientating testing. It's very simple, and if you fail with UL 94, in most cases it doesn't make sense to go on with this formulation. So then that's what we can do where we can help. So we can do these testings in our laboratories. When you do these testings, you have different kinds of characters you have to achieve. Time of fire, dripping of material into wool or something like that, so on and so forth. So that is the first thing you have to talk about. What is the standard you like to achieve? Now I want to talk a little bit about the working principles of flame retardants. You have chemical and you have physical effects. If you have chemical effects, you must make a difference between three different mechanisms. One is a radical formation, which avoids the oxidization of your material. One is a charring effect, which builds up a layer of carbon on your part, and so separates the material from the fire. And then you have the interminescence, strong hard word, interminescence effect, where you have a kind of foam formation, which also makes a separation between fire and material. And you have the physical effects. Very well known is a cooling effect by aluminium trihydrate. So if you have a fire, you have a formation of water by the aluminium trihydrate, and this water is cooling the flame. It's very simple. And in most cases, this is the main material which is used in composite industry because it's cheap and it works. On the other hand, you have to use lots of material, 200, 300 parts into your composite, which makes it not so easy, which makes your part very heavy and lowers the mechanical properties. Then you have the formation of inert gas and a dilution effect also. And what you use for that is nitrogens and phosphorus materials. When we're talking about phosphorus materials, you have to be aware about regulations, because every molecule which has a strong effect has also a strong side effect. And lots of these materials are regulated under dual use or chemical weapons regulation. Sounds scary, but it isn't. It's a matter of documentation. That's all. We can help by that. And the best effect, well known, are halogens. Halogens building up radicals and has the best effect in terms of flame retardants in combination with antimony trioxide, for example. But nobody likes halogens since a couple of years because the formation is you have also a strong side effect by building dioxides and also by building chlorine acid gas, which is toxic. So, what are the physical properties of a flame retardant? You can go from liquid to pasteurous to powder. Iminophos can provide all these materials. As you can imagine, everybody wants to have a liquid material, transparent, very light. This is the most expensive one, mainly based on phosphorus chemistry. Pasteurous materials are mainly used in phosphorus plasticizers by it's a mixing combination of antimony trioxide and halogen materials. Good effect, but also there's a toxic effect. And last but not least, the powder ones, aluminium triiodide, and but also we can provide phosphorus materials like ammonium polyphosphate, for example, and or nitrogen-based melamine materials. What you see on the right side is a typical DSC. What you want is not to have a negative effect on your glass transition temperature. You will never achieve that, that's for sure. Your glass transition temperature always will go down, because if you add 10, 15, 20 parts of a flame retardant in your composite system, you have a different system. You have a different resin, that's for sure. So, last but not least, regulatory. In the last years, regulatory overwhelmed us to do registrations in different countries for different standards and regulations. Well known as the REACH regulation is the European Union, active since 2018. After the Brexit, UK made their own REACH, so we have to do it once again, everything, if you want to export material to the UK. And last but not least, the Republic of Turkey, KKDEK, which is also a Turkish REACH. At the moment, the deadlines for the registration are postponed because the Turkish authorities are overwhelmed by requests for registrations. And so they postponed it to 2 or 3 years, I think. Nevertheless, you have to be aware about dual use. OPCVW, which means chemical weapons regulations, so on and so forth. A lot of things you have to think about. But we are well known about these regulations, and we can help if you need support on that. So, before you start to start a formulation for your composite, what is your target? What do you like to achieve? What is your price range? What are the mechanical and chemical properties of your composite in the end? There are things and questions you have to think about before you start a new formulation. And this will also lead to a decision which kind of flame retardant is the best one for your composite. So when you start on that, talk to us. And now I'll hand over to Mike again. Thank you very much. That was a small idea about flame retardants.
Yes, thank you very much. Yeah, the flame retardant information we gave were things to think about it, which we normally do on a daily basis, because these are the most often questions from customers. It's a little bit difficult to get all of them into a short presentation because it's divided always by the different production methods. So pultrusion, flame retardant should be more on the liquid side. SMC is looking sometimes more for powder. So it's always an interesting discussion and an open topic always. So as Thomas said, if you're interested in any kind of flame retardants or knowledge about it, just talk to us, stop by at the masking booth. It's B8, we will be there today and tomorrow all day. Now, he handed over to me to talk about Luvatol. Now we go to a more specific topic, and a topic which we know very well because we produce MGO thickeners for more than 40 years now for the SMC and BMC industry. I just go briefly over where it's used because I'm not sure if every one of you comes from the SMC industry. So an MGO thickener is used in the SMC production with the resin, with the uncial polyester resin, before introducing the fibers, mixing very well to make sure that the liquid resin you have over time goes from liquid to a leather state where you can roll and store your SMC. And I want to go now in the next minutes over what is Luvatol, how it is working, what you should consider when you try it, and of course, since we sell it, how we can support you with it. First of all, like with the flame retardant, as Thomas said, you need an idea about the formulation itself. So an SMC formulation is normally a well-secured secret for all SMC companies. And it's like spicing a meal. So you have a lot of things in there, and everything interact with each other. And normally, and luckily for us, because we have the knowledge and can help, it interacts also with the thickening agent, the Luvatol or the MGO thickener, how you want to call it. So in an SMC formulation, there are many things. Of course, the obviously are the resin, and of course also the reinforcement. I apologize, I forgot the most obvious one, the flame retardant here on the list, which we just talked about briefly. But these are also in there, a liquid or solid state. You have a colorant, you have normally lots of styrene if you work with polyester resin, initiators, fillers, and many more things. And all of them interacting with each other, so you need a really good balance of all these products in your formulation. And that's why SMC customers like to hide their formulation. And they are all different based on the final purpose. If it's construction, if it's automotive, they are totally different. And so are also our Luvatol. Just a brief introduction, what is a Luvatol? Luvatol is a blend of magnesium oxide or magnesium hydroxide or a mixture. And even within the MGO, there are always a lot of differences in a polyester resin. Of course, there are lots of other things inside, performance additives and well-known secrets for the process, which we not reveal here, because something we need to have for ourselves as well. And this material is used mainly, again, in the SMC BNC industry. And there's a really good reason for it, which I want to tell you right at the beginning, is basically to reduce costs. Because in the industry there are lots of different solutions for thickening. Many like to use powder materials. Many like to use other initiators to have a thickening effect. And the Luvatol there has the advantage in process control. So it's not like you can, for example, calculate a powder against a paste. It's more like look at your process, how much scrap you, for example, produce during your SMC process because something is thickened, some parts are not, some rolls are, have a lacking effect, so you have an egg form which you cannot sell anymore. So the reason, and that's why I want to tell you before I explain you all the things in the next minute, is to optimize the process and at the end to get a more economic solution for your process. And how does it work? So this is independent if you use a paste or a powder. The thickening effect is always the same. You have an MGO. Here you see these little bubbles, that's our MGO. And there's one thing which is the most important at the beginning. It works with two kinds of resins, with polyester resin and with vinyl ester resin. The reason is the MGO builds up clusters with the acid group at the end of the resin chain. And that's something you need. If you don't have it, you can put as much MGO in there as you want. You get, of course, a higher viscosity because you insert a lot of powder, but you will not have the thickening effect, which helps you to have a better molding process and have a lesser state SMC at the end, which you can store. There's one special case, and that's vinyl ester resins. It works. Normally, the vinyl ester resin is modified by the resin producers. I saw a few of them here, which probably know much more about modifying resins than I know. But normally, we recommend our customers to try it. So in this case, we use the most powerful MGO we have as a paste. We add it to the vinyl ester. And then we will check if it works. There are lots of things besides the formulation which influence the test and the usage of the MGO, which is, of course, the grade, which is the resin properties, moisture, and many more. What do you get out of the Louvertool is then, if you use it instead of, for example, a powder, you get a constant thickening performance, which is always the same. If we have here people who are using MGO powder in SMC and BMC, you well know that even from batch to batch, you have to I just have to be careful here, to insert more or less material and to adjust during your production. So it's always like a handling up and down. And that's different with the Louvertool. These handling and these setting of the materials doing by us then. You have, of course, a better dispersion because it's easier to enter a liquid in a liquid instead of lots of powders. It's dust-free, and it's more resistant against moisture, especially some parts where we put, for example, moisture absorbers in there. But on the other side, it's not like the ultimate goal you can get, which solves all your problems. Of course, there are lots of things you need to consider when you test or want to change from powder to a paste, when you want to use Louvertool. Some are pretty obvious, and some are not so easy to identify. That's why we always recommend to test it out. And like with the flame retard, it's just to talk to us. We are happy to share any experience we have. We sell Louvertool, again, for over 40 years in basically worldwide. And the reason it's different is not only the grades, the moistures, also the local possibilities. So that's why we, for example, already developed over 30 different grades of Louvertool. We have, for some areas, for BMC, really economical solutions. We have customized solutions, for example, not only for the SMC, also for the CIPP industry. Some people are asking us for food contact, for drink water applications, or for a high transparency, which are not interact with any kind of color in the SMC formulation. That's all possible. So we are also used to tailor-made the material because we have a really excellent access to the magnesium oxide market worldwide. So we have access to all kinds of different grades, and we are used to play around with it a lot. Of course, again, there are some things you need to consider. Some are pretty obvious, like the MgO grade or the Louverture grade. The resin, which then is easy for us because we just forward you to the resin supplier. The loading level, temperature, storage time, and water content. And how these influence not only your usage, if you use Louverture, I'm really happy, but also the usage of powder and any other kind of MgO thickeners. I want to show you in the next minute so that you get an idea where you probably, if you are not doing it right now, where you probably can play around to optimize even more. First and easiest thing is the Louverture type. Again, we have totally different grades, not only with magnesium oxide, also hydroxide can be used to thicken your SMC process. So here on the bottom, you see a chart with a viscosity. We measure a complex viscosity with a rheometer and the time, thickening time. We always use the same resin. In our laboratory, we use an AOC resin always for testing, and we always use the same amount of magnesium oxide paste in it to compare. For example, the MK35, well known here in Turkey thanks to our friends from Maskim, is our most standard grade. The DK35 is then a mixture of a magnesium oxide and magnesium hydroxide. EH35 is magnesium hydroxide pure in a blend. And you can see the difference over time. Here it's time in hours. It's pretty obvious. So that's the easiest thing you can play around with. If you want to have it slower, use a less active MgO or Louverture type. On the other side, the same Louverture type that's on the right side here, you see the same MK35 curve here. The full formulation, you remember the example with the spices, the same Louverture in different applications leads to a totally different thickening. It's totally different if you have a truck one, if you have an electrical one, or if you have a structural formulation. Based on what you put in, also the thickening is totally different. So if you want to have it slower, we recommend to change the Louverture type or to play around not only with the type. Of course, obvious is also to play around with the amount. Also changing the amount leads, you see again, time versus viscosity, leads to totally different results, from really fast to absolutely slow. There are, of course, also some levels. You cannot go over a certain level, then nothing happens again, and you cannot go lower. This is important because we have often, or what means often, we get from time to time the remark that the thickening is totally different. And when we ask the people, do you level it out always at the same time? They said, no, we just have one guy with a bucket who just grab a little bit and put it in. It's roughly the same. But this is already leading to totally different thickening performances. Most important, that's why we normally like the fall season, because the temperature is always at the same level, is the temperature. During your process, in your workshop, from the resin over the additives. The most changing, or the most often remark for changing and thickening, is because of the temperature. Here again, viscosity and time. This time you can see it's not equal, it's 1, 10, 100, 1000. And you can see here, for example, the MK35 at 15 degree, 25, and 40 degree. These are the first ones. And only the temperature difference about 10 degree makes it already close to 100 times faster in thickening. So a control of the temperature is the most important part we can recommend. And this is independent if you use a powder or Louverture paste. This goes for your whole process. Of course, also in your maturation chamber. On the other side, you can use it. If you want to have it faster, just set the temperature up. That's an easy change. Another topic is water. Currently, we get often the request, because people try to make their SMC a little bit lighter, we get often the request that the thickening performance is off, and we should investigate what happens. And at the end, we found out that some of the people change their solid additives, like for example the zinc stearate, with a liquid one, which contains a lot of water. Or if they add thixotropy additives to the resin, there are also solid and liquid ones. And the liquid ones incorporate, sometimes it happens on purpose, sometimes as accident, water to the formulation. And here, same curve, it's always the same for us, so it's easy to identify. You see that the water content, even 0.3 pHr or 0.1 pHr, leads to a totally different thickening. We always compare that adding water to a SMC formulation with a thickening agent is like fishing with dynamites. So you can put it in a sea and you get some fish out, but if you get 5 or 10 fish, it's always a little bit different. So at the end you have success, you get your SMC, but the process is not really controllable. And last but not least, since we are responsible for the Louvatrol, we made, of course, also lots of tests with powderous materials, with MgO, because we use it ourselves. We use the MgO to make the Louvatrol. So we know about the properties, we know also about the problems which happens. We made also lots of tests with pure MgO. Whoop, where is it? We just add MgO in the resin and just mix it, without any additive, without our normal production process. And we use our Louvatrol as well, which is here on the red curve. And the difference we note that even if you have MgO powder, the same grade, the same batch, sometimes because of the size of the MgO and also on the shape on the MgO, the thickening even within one batch is totally different. And that's then our job. That's what we are doing with the MgO. We test all this and we make sure that you always have the same thickening effect. So for example, here's our MK35NV. We made lots of batches for different countries, for different customers. And we adjust during our production the Louvatrol so that you always have the same thickening effect, that you always get the same result. And at the end, it's not a calculation then against powder versus paste. It saves you time, which you normally need to adjust the powder all the time. It saves you cost, because at the end you can use more of your SMC. And it gives you more security that you can, of course, hold your promises to your customer. So to summarize, since we produce this quite a long time, so you get a constant thickening performance, a perfect reproducibility, you have a high degree of activation, you can rely on our help if there is something off, if you have a new product, if you need a new Louvatrol type. It's easier to disperse. You have no agglomerates, which you normally have to filter then at the end. And additionally, you don't have the problems with the MgO powder you normally find if you have, I saw it here on the floor, white parts, if you produce pure white parts. In every MgO batch, you will find some black dots, which you will find later on also in your final products. That's something you can avoid as well. And of course, it's more resistance against water, because there are also some types which have water absorbent in there. That's the part about the Louvatrol. So that concludes our presentation. Again, I want to invite you to the Muskin booth. We will be there today and tomorrow to support you with the Louvatrol, with flame retardants, with any topic you might have. Also for the other products we have, other additives for the SMC industry as well. And I would like to thank you for listening to Thomas and to me at this hour. Thank you very much.